Boys and girls, welcome back. So we are now wrapping up our study of electrochemistry, and like I promised you, I've explained all the concepts, especially this last part where we were talking about batteries, torches, car batteries, and also the industrial applications where we showed that we can use electrochemistry in processes such as production of chlorine gas from brine solution, that is the salt water from the ocean, the production of hydrogen by electrolysis when you are doing splitting of water. You can also do electroplating and also break down compounds by electrolysis in mining, where you can do purification of mineral ores using electrolysis. So let's see how we can make use of that background information and answer a typical examination question like this one, in which question 9, I want you to take note that this question has got 11 marks, and what is important for now for this revision, we want to see that do we have enough information to address the questions raised here, and then we'll work it out together. Okay. So the question has got background information. Says that the diagram below shows an electrolytic cell used to electroplate an iron rod with copper, and the solution X is made up of an unknown nitrate. Okay, so a quick recap, boys and girls. Here we used an example of carbon electrodes, where we end up seeing copper forming around the carbon electrode. So even in our previous discussions, we said we used electrochemistry in dental voltaic cells, or in other applications we represented, like for example this one. You remember this, where we show that where we've got a copper cathode and a zinc anode, we actually saw the zinc going into solution through this half reaction, where zinc solid dissolves to give us zinc ions and the liberation of 2 electrons. And the electrode itself, look what happened to it. It started getting thinner and thinner. And then what's happening on the copper electrode, you can actually see the original copper electrode there. But after the reaction, you can actually see that it was becoming bigger and bigger as more copper atoms were being deposited on the surface. So this is the mechanism of electroplating, where deposition of atomic particles take place around a material which is being used as an electrode. So you'll see that in this representation, we say that this is a zinc copper reaction in a voltaic cell, and in this case, each half reaction will give you a clear idea of how do you choose materials which we are going to use in your electrochemical cell, and also make an intelligent deduction of those materials we are using. Why and where do you place it as an anode or a cathode, depending on the electrode potentials, which we also say that when you do the overall cell potential, you should be able to determine that with a galvanic cell, when your overall cell potential is greater than 0, it means the reaction can take place and it's also spontaneous. While if it is less than 0, we say the reaction is non-spontaneous and it does not take place. And we say the opposite is true with the electrolytic cell. We are saying that for us to find out that the reaction is going to take place, the E cell, the overall E cell, should actually be negative. That's what shows you that the reaction is going to be possible. And from that knowledge, you are able to decide and choose which materials you are going to pick up and use them to make your electrolytic or electrochemical cell. Okay, so going back to our information we are sharing here to answer this question and also our representations we made here, I think just to give you a quick summary, I summarized by telling you that the comparison between a galvanic or a voltaic cell is different from an electrolytic cell in the sense that I'm starting right from the diagrammatic representation where I say that the moment you see two vessels used with the electrodes different, look like in this case this is electrode M and electrode N, that automatically means that they are different, and we can have two different electrolytes and there is no an energy source, you automatically know that we are dealing with a voltaic or a galvanic cell. While if the reaction, the setup is presented like this, you automatically know that this is an electrochemical cell where all the electrodes are in the same vessel, same solution, and we need a power source. So this is what you guys confuse in an exam, where especially you are asked to show that to show a difference between a voltaic or a galvanic cell and an electrochemical cell. And also remember what I emphasized on the anode and the cathode, that in the galvanic cell, the cathode is negatively charged, while the anode is positively charged, and vice versa. The opposite applies in an electrochemical cell. Okay, so we will come back to these questions here, but what I want us to do first today is to go to our 2018 grade 12 paper 2 May-June and answer these questions using the background information we were sharing. So we are going to answer this typical examination question, Physical Science grade 12 paper 2 2018, the May-June paper, like I said. So the instruction here is saying the diagram below shows an electrolytic cell used to electroplate an iron rod. Remember, boys and girls, we are electroplating. So what should come to your minds immediately is that electroplating, we are supposed to have ions moving from one point to another. And in a previous representation we illustrated, we showed that the material which is going to be electroplated is the one which is going to be used as the cathode, while the material which is going to be to electroplate will be either in solution or is presented as an anode. Okay, so if we study this diagram very well, we can see that this is the iron rod, and we have got the material A, which we don't know, and then our power source and solution X, which we are saying is an unknown nitrate solution. Okay, so we are saying that solutions such as solution X are always used in electrochemical cells. So here's the first question. boys and girls, I want you to see that this is just for 1 mark, so it shouldn't give you much trouble how to address this question, okay? They're saying, write down the general term used to describe these solutions. Oh, ladies and gentlemen, this is very simple and straightforward, because we know that any solution which is made up of ions that are able to carry around electrons in an electrochemical setup is called an electrolyte. So yes, solution X is generally referred to as an electrolyte, and in this case we are saying this electrolyte is some kind of an nitrate in aqueous solution, okay? So the next part is saying, what is the function of these solutions in electrochemical cells? We've just mentioned it. We are saying this electrolyte is composed of ions, and we are saying ions are capable of carrying around electrons through the solution, where they are being generated to where they are being given away. So like in this case, we are going to find out, since we are saying we are going to electroplate an iron rod with copper. So what it means is that this iron rod is going to end up having copper ions surrounded around it, okay? So from that, we can preempt or make an intelligent prediction that since the iron rod is the one which is going to be electroplated, then it should be the cathode, while A should be the anode. Let's see as we answer the questions that follows. So the third question is saying, write down the formula of solution X. How are we expected to know the formula of solution X? Yes, we can, because the instruction is saying we are going to electroplate an iron rod with copper. So meaning that whatever this solution is, it's a copper solution. And so what is it? They are saying solution X is made up of an unknown nitrate. Oh, so let's marry the two, copper and nitrate, to make a copper nitrate. So how do we represent that, boys and girls? We are saying copper, we know copper ions, they carry 2+ charge, while a nitrate ion carries a negative charge. So to balance up things here, it means we will need 2 of these. So when we put together a 1 copper ion and 2 nitrate ions, we have copper nitrate like this, 2 of them like that, okay? So this will be the solution where X, which will enable us to electroplate the iron rod with copper with copper, and so automatically what it means is that the copper ions are coming as Cu2+, and then when they get here, they pick up electrons and then undergo a phase change from ions to solids, and then they deposit around the iron rod. So meaning that the copper ions will be slowly but surely getting used up from the solution as they solidify and stick to the iron rod, okay? So here we are saying that which electrode, A or iron rod, is the negative electrode, and give a reason for the answer. So from what I've just said now, we are saying for the copper to electroplate the ion, it must come and pick up electrons on the iron rod. So meaning that this iron rod is pregnant with electrons. So since the electrons are all in this iron rod, so that means the iron rod is negatively charged. While this is positively charged because the electrode A loses the electrons into the solution there, and then for that reason it is positively charged. So we are saying to answer this question, which say which electrode A or ion rod is the negative electrode, we are saying it is the ion rod. Why? Because we are saying reduction is taking place on the ion rod. Okay. And then question 4. So this is for 2 marks. 1 mark is for identifying which electrode, and then another mark is for giving the reason why that is happening there. Okay. So here is another question. We are saying write down the half reaction that takes place at electrode A. Electrode A. So, boys and girls, we are saying at electrode A, we should be able to have copper going into solution so that it moves towards the ion rod, which is negatively charged. So what it means is that we are supposed to generate our Cu2 plus from electrode A. So to answer the question, we are simply saying we need to write the half fraction that takes place at electrode A. So at electrode A, you can actually see that we are going to have copper, atomic copper, losing electrons. Since we said on the ion rod, reduction is taking place, so oxidation should take place at the electrode A. So oxidation is loss of electrons, so we are saying the copper loses electrons like this. Okay. So it is these electrons, these ions of copper which are generated at the A electrode or the cathode, which will now go to the anode, the ion electrode, and be reduced and then deposited around the ion and form a thin layer and electroplating the ion rod. Okay. So this is for 2 marks, and you should be able to show even the standard states of the material of the copper. So like in that case, you get a mark for this expression, you also get a mark for this and that, to show that there is a phase change, because you might be asked later on to show a cell notation for this representation we are making now. So for those 2 marks, don't miss out. Now, then the next part, it's saying electrode A is now replaced by a silver rod without making any other changes to the cell. After a while, 2 metallic ions are found to be present in the solution. 2 metallic ions are found to be present in the solution. Name the 2 metallic ions present in the solution. Boys and girls, is this going to give you any problems? Because as far as I'm concerned, we know that initially, when we answered this question, write down the formula of solution X. We agreed that is the copper nitrate, meaning that in solution we have got copper 2 ions. Okay, but now we are now making electrode A a silver rod, and we know that on that electrode, the electrode itself is going into solution during the electrolysis process. So it is breaking down, it's dissolving and going into the solution as ions. So now, since this is now what do you call it? The cathode, we are saying silver ions, just like this one. Okay, so let me write it next to this, and so that you understand what exactly is happening. So earlier on we said this is what is happening at electrode A, so we end up having copper 2 plus ions in solution. But now that we are using silver, so it's going to be silver reacting like this, which goes into solution to give us silver. So silver, when it breaks down, it gives away 1 electron. So it's going to be plus like this, plus an electron like that. Okay. So what it means is that our solution, remember the instruction here, it's saying 2 metallic ions are found in the solution. Why? Because when we replace the electrode A with silver rod without making any other changes, meaning that our electrolyte still remains the same, a copper nitrate, where copper ions and the nitrate ions will be there. But now we are now bringing the electrode as silver, and silver is going into solution to give us silver ions like that. So obviously what we are going to have as the 2 metallic ions present in the solution is going to be the copper 2 plus and the silver plus ions occurring together in the solution. Okay, so that gives you a 2 marks. Okay, and then the last part of the question is saying refer to the relative strengths of oxidizing agents to explain which one of the 2 ions will preferably be involved in the plating process. Okay, so how do you do this? Do you need to do some mathematical calculations, or do you need to use your background information of the reduction potentials and reactivity of these materials to see which one reacts more preferably than the other? So you'll see that I'll take you back to the reduction potentials table. It's up here. Right, there we are. We want to see what is the potential for this half reaction and the potential for that half reaction. I'm going to put down the values over there. So let's look for copper when it breaks to form copper 2 plus. Where is it? Do we have copper here or silver? Yes, here we are. So copper 2 plus, it gives us this. So the value here is going to be minus A, because this is for copper 2 plus, aqueous plus 2 electrons to give us a copper solid, and it's plus 0.34, but we are representing the opposite here. So it's going to be minus 0.34. So I'm going to say the standard electrode potential here for this is going to be minus 0.34. And then if we look for silver, let's look at silver Ag. Do you see silver, zinc? I don't see silver yet. Ag. Okay. So should be on the previous page. Silver on its own is this one. Yes, here we are. You can see that this is silver plus an electron to give us silver solid. So if we do the opposite, it's going to be silver solid to give us silver ion plus electron. So here is the value. I hope I'll get it right this time around. Oh, it's going to be minus 0.80. So the electrode potential for this one is going to be minus 0.80. So boys and girls, this is where all the trouble starts. These values, do they mean anything to us in terms of the electrochemical interpretations we are supposed to attach to these half reactions? So we say that at the anode where oxidation occurs and at the cathode where reduction occurs, what we need to determine is which material should stand in as an anode and which one as a cathode. So in this case, we are saying that the reactivity of copper compared to that of silver is measured by their respective electrode potentials. So what we measure here, as we go down, the standard electrode potentials is decreasing, meaning that these materials, they are becoming less or less more reactive. So meaning that the silver is going to competitively replace copper in its compounds since its value is more negative than that of silver has got a more negative standard potential value than that of copper. So for that reason, boys and girls, we are saying to answer this specific question, if you look at the strengths of oxidizing agents, so the more negative the electrode potential is, the more oxidizing it is. So for that reason, we are saying silver ions is a stronger oxidizing agent because it has got the highest standard electrode potential, the most negative, minus 0.8, than copper, which has got a smaller value of minus 0.34. So what it simply means is that the silver ions are going to be more reactive and go and coat the iron rod more strongly than the copper if both ions are occurring together in solution competitively. So we are saying that the copper ions will be reduced more, the silver ions will be reduced more readily to form silver, while the copper ions are less reduced. So for that reason, you see that where the copper and silver ions are occurring together in the solution, preferentially the copper will go, the silver will go to the ion electrode than the copper ions in the solution. Okay. So here we are saying for 11 marks, this is how you address a typical examination question. And you see that it was easy for us to sail through this question because we took enough time to explain the whole concept of electrochemistry and made a distinct comparison between voltaic or galvanic cells and electrolytic or electrochemical cells. And with that information, we used that background to address this typical examination question. So is that all what we can be asked? There are direct questions which we can use to practice, to implement and apply the electrochemical background information we were dealing with in the past two sessions. So like for example, here we are given this situation where you've got an electrode M and an electrode N, and we are saying this is a moistened wick, which is going to be used as a salt bridge, and this is a voltmeter which is going to measure the electrons which are going to be transferred around here, and automatically when you see this arrow, it's telling you the direction of flow of electrons, of which from this setup we can make an intelligent deduction that this is a voltaic or a galvanic cell, and from a galvanic cell, the fact that the electrons are going this way, we know that electrons move from the anode to the cathode. So here is our representation. So if we are to answer the questions here which are saying, write down the values of the standard conditions under which this cell is operating. Oh, this is very simple and straightforward, boys and girls, because you can actually see that the standard conditions is such that the temperature is at 25 degrees Celsius, and also the concentrations of the electrolytes are all 1 molar. And the pressure is 1 atmosphere. So for 2 marks, you get that for giving that reason. Now, which electrode did the learner choose as the anode, and give a reason for the answer? That's very simple, isn't it? So like I said here, because of our understanding of the representation of a voltaic diagram, we are saying electrons move from the anode to the cathode. So automatically electrode M becomes our anode. And for the reason being that from this diagram, the direction of flow of electrons is from left to right, and meaning that the left side is our anode where electrons are coming from, and the right side is the cathode where electrons are going to. So for 3 marks, you get that for that. And then I was saying, write down the equation for the half reaction that occurs in the half cell with electrode N. Oh, boys and girls, remember we say that reduction is taking place here, and we said, what is reduction? Reduction is when a species is gaining electrons. So you are going to write an equation in which the species you are going to use here is going to pick up or gain electrons. Okay. So for us to answer this, like I said, we know that in a voltaic cell, just like we were making representations all along, like this, you will see that on the anode, oxidation is taking place, electrons are being lost, and then at the cathode, reduction is taking place. So whatever species you are going to represent on the cathode, it is supposed to undergo a reaction in which the material itself is an ionic species, and then it picks up electrons and form either a gas or a solid. So we can show similar representations like this, or like this, where we are still saying the same thing, that at the anode, like in this case, these are carbon electrodes, and we've got iodine here, which is being oxidized while the manganate is being reduced. And for that reason, you see that our anode will be represented as a negative electrode, while our cathode is represented as a positive electrode. So whatever equation you are going to use to answer this question here, you are supposed to show reduction taking place here for 2 marks, okay? So lastly, like I said earlier on, you are expected to write down the cell notation for this electrochemical cell, and we agree that for a voltaic or a galvanic cell, always what you have as the anode is represented on your left, and what you have as your cathode is represented on your right. And on your left, you start with the solid material and you separate the phase transition with the ionic species, and then you put a double slash and you show the ionic species of the cathode and the solid species of the cathode, and then you will have a clear representation of the cell, just like we used this example here. And I emphasize that the physical state of the materials is very, very important because it tells the order of arrangement of materials in your cell as you are representing it. So like in this case, a solid changing into ionic species, and then a salt bridge, and then ionic species to a solid. That's how we arrange our materials in any electrochemical cell representation. Thank you very much, ladies and gentlemen.